Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.2 Host and Application Security. Now let's get started. So this video is going to be another kind of a longer one. I believe we have 17 slides to go over. So bear with me. Again, if you need to pause, please feel free and come back. And with that being said, let's jump right into it. So, Domain 3.2 will primarily discuss technical solutions for security for our existing endpoint systems. So, the first endpoint protection we will talk about is AV. AV is antivirus software. Antivirus software scans, prevents, and deletes viruses from your workstation. Every antivirus software can be part of a whole suite of endpoint protection solutions, or it can be standalone software that's installed on a workstation or a server, meaning that we can have like an agent based or a server based antivirus solution. So in our enterprise, just to draw it out real quick, we could have a server that runs like a McAfee server that all these computers respond to and get their configuration from. Or individually, we can have McAfee not getting configured from any server, right? So we can have two different implementations along with our antivirus software. So AV or antivirus software has different detection methods for detecting viruses on computers. Signature-based scans rely on a database of other viruses to detect viruses on your workstation. So signature-based, imagine we have a Excel spreadsheet of all the different viruses and their unique hash or signature. We can use signature-based scans on our systems to see if any of those already existing ones are on our systems. Then we have heuristic-based scans, which rely on behavioral recognition for detecting viruses. So a little bit more advanced, right? And you can combine this with signature-based detection to actually have a more robust AV suite, right? The next thing we're going to talk about is anti-malware. So anti-malware is typically software that's a part of antivirus software suite, right? But it's going to specifically protect against malware like worms, Trojan, bots, and ransomware, right? So again, this can be standalone. Like there's technology or software out there like Malwarebytes that'll just be anti-malware. But if you're installing something robust and enterprise like McAfee, you'll get antivirus plus anti-malware. And then we have EDR, which stands for Endpoint Detection and Response. This is a endpoint security solution that creates automated response and analyst capabilities. So EDR is a generally newer technology that is going to actually use machine learning to automate malware detection and report deviations to an IT administrator or security administrator. EDR can also be configured to isolate systems and perform root cause analysis without administrator intervention. So what this is a technical detective control that we can install on our systems to have faster remediation by faster response times that are automated and get reported to our IT team or our security team. And then we have DLP, which we've talked about earlier, data loss prevention. This is a software or application that prevents data exfiltration from your network. For a DLP system, you must first classify sensitive data. So you got to tell that DLP software what is sensitive. And then you got to install the DLP system. So DLP can be installed on endpoints or gateways that are the entry and exit points of your network. DLP can also stop external devices from being plugged in and can also perform deep packet inspection on your host. So DLP can also be a part of that AV suite, right? So not all these have to be standalone technologies that we implement. You know, McAfee or other AV software or really security endpoint software can package all this for us, right? And then DLP, what it means by classifying it is essentially in that DLP system, however you implement it, whether it's server based or individually host based, you got to tell it what is sensitive. So if you want to stop, let's say, for example, social security numbers from leaving, you got to tell that DLP system to look out for expressions or texts like this, right? 0 through 9, and then has this format. That's just a very basic example, right? And a lot of times now there's going to be stuff in place that uh, your DLP systems, you don't have to granularly go step by step, tell it what's sensitive. They might have packages that say, okay, this will stop PII and PHI from leaving your network, right? And it comes with the software seat you installed and paid for. And then we have next generation firewalls, which do more than traditional firewalls. With a traditional firewall, you'll permit or deny traffic based on IP or protocols, right? Layer 3 and layer 4. Well, with a next generation firewall, it can perform deep packet inspection and can be granular in its approach to denying and permitting traffic. A next generation firewall can also be deployed and managed from the cloud. Next generation firewall benefits are also the context aware filtering it can provide for your enterprise. And what we mean by that granularity is something like this. So let's say your users need to be on Facebook Messenger, right? That's how they can communicate to loved ones or outside of your environment. Let's say if you're in a real secure area, but you don't want them browsing Facebook. Well, in your context aware next generation firewall, you can specify that. You can say, allow Facebook Messenger, but deny the browsing of the actual Facebook website. And that's what we mean by its granular approach. And then we also have host-based firewalls. A host-based firewall are software that runs on endpoints and will permit and deny like traditional network firewalls, but only for your systems. These firewalls can also permit and deny based off application. If you go to your Microsoft Defender, you can permit some applications or services on your network or on the endpoint, excuse me. So a standard host-based firewall used in enterprise will come with something like the McAfee software suite. It'll run the firewalls on your endpoint systems like your computers. And then we have Windows Defender Firewall, which comes standard with Windows machines. If you're ever getting like weird pings and you're troubleshooting a network function that's not working on users, this is also a good step. Look at your host-based firewalls, right? I know when I do my CCNA courses, I run an application called GNS3. And when I got brand new computers running Windows 11, GNS3 and my VMware Type 2 hypervisor weren't able to communicate because the McAfee firewall that came installed was denying it. So I had to go ahead and allow that application through, right? Some more endpoint protection are host-based intrusion prevention systems, which will analyze traffic on endpoints to prevent malicious traffic in software. HIPS can also take action against malicious traffic. So if there's a malicious TCP connection, it can actually go ahead and cut off that TCP connection for you. Another thing a HIPS can do is also detect malware and alert administrators. So HIPS is a preventative control that will stop real-time incidences. So HIPS can also affect your availability, right, if improperly configured. But along prevention, they can also do detection, okay? Now, let's say you don't want something intrusive on your network, but you still want some way to detect host-based intrusions. Then we're talking about HIDS. So HIDS is very similar to HIPS. It's installed on endpoints, but it can only detect malicious traffic in software. HIDS does not take action against malicious traffic. It will only alert an administrator. However, HIDS will not cause an outage. While HIPS can be very helpful in prevention, it can also produce false positives that could potentially cause outages on your endpoint systems. So HIDS is more of just a detection method that can help us remediate malware, whereas HIPS can just stop it before it happens, right? It's a prevention control. Now let's move on to boot integrity. As administrators, we spend time on our endpoint protection for our operating systems. But our endpoints must also be secured before the operating system is even loaded. We must also protect the boot process. In the boot process, we want to ensure that the system is not altered. We call this having a secure boot. The unified extensible firmware interface is going to be a way we can have secure boots. This is the replacement for the BIOS test on our systems that you may be familiar with. UFI, or Unified Extensible Firmware Interface, will test hardware to ensure it has not been altered and load the fundamental drivers and boot the OS. UFI has built-in security features like Secure Boot, which will only allow the system to boot trusted OEM hardware. OEM standing for original equipment from the manufacturer. And then we can also do something called measured boot. The measured boot will hash all parts of the boot process and then store that hashes in a TPM. TPM standing for a trusted platform module. The boot process, when we're using measured boot, will then compare those hashes upon every boot and alert an administrator if there is a change. Oh, excuse me, I erased that. Let me write that out for you. Again, OEM, original equipment, manufacturer. And then TPM, which we're actually going to discuss further on in the series, stands for Trusted Platform Module. All right. Moving on into database security. So now we're going to talk about securing our actual databases and ways we can do that. So tokenization takes sensitive data and converts that data into a token, which changes the precise text data being sent, right? So this technology is typically used in mobile banking or mobile payment systems, where instead of sending our debit or account information across the wire or clear text, we create a token for it. And then we have hashing. As discussed in previous videos, hashing will take a clear text data, run a computational algorithm on the data to create a message digest. And we can use this for integrity, right? And in our previous video, Cryptography Concepts, we did a little bit of more of a deep dive into hashing. So if you want to check that out, please feel free. And now let's go into some application security. Input validation. Input validation is a protective measure that protects your front-end websites from injection attacks. Input validation is a rule that only allows specific text to be entered and processed on your websites or applications' input fields. For example, if you have proper input validation on your website, a threat actor would not be able to type HTML script brackets in the input fields of your website. Now, we talked about this more in depth in Domain 1. So again, if you want to check out those videos, you can. But essentially, input validation should always be in our applications and our websites to ensure we can't be vulnerable to injection attacks. A secure cookie will only be sent over HTTPS to a web server or website. So we know cookies are always going to be on our websites, right? And they store data for us and make our browsing easier. Well, cookies are not always sent securely. So when secure cookies are being used, threat actors performing a man-in-the-middle attack cannot manipulate the cookie of a web session because they're going to be protected over HTTPS. And then we have HTTP headers. HTTP headers are additional information that gets passed in an HTTP session. The HTTP header will include a request and response section. Now, there are a lot of different uses for an HTTP header, like telling the web server the preferred formatting of a web page. Or in our case of security, an HTTP header can include an HSTS request that will actually enforce the use of HTTPS. So I've definitely run into this before where I'm not allowed to get to a website because their HTTPS session isn't validated. They don't have a valid cert. So if we have HSTS enforced, it won't let me access that website. Another protection that an HTTP header can provide for us is different X-frame options, which will prevent clickjacking attacks. Clickjacking attacks are the malicious practice of manipulating a website's user activity by concealing hyperlinks beneath legitimate clickable content, thereby causing the user to perform unaware actions. So what do I mean by this? So it says click here to see this deal, but actually you just installed malware, right? So X-frame options in the HTTP header can prevent those clickjacking attempts to be transferred to the client from the web server. And then we have code signing. Code signing is an application level protection that will verify and authenticate source code. Code signing will allow developers to digitally sign their applications, their drivers, their executables, and any software so that end users can verify the code has not been altered. This ensures integrity and non repudiation of the code, and will also need PKI and public key infrastructure to make that work. Some more application security. So, application level security will also include permit and deny list. An allow list sometimes is referred to as a whitelist. This is a list that will only allow specified applications to be installed or services to run, just like I talked about that GNS3 firewall incident I had. With an allow list, if only 5 applications are on that list, that means you can only download those exact 5 programs. This requires much more administrative overhead for determining which applications should be allowed, right? So essentially that means if you have a user in the R&D department that needs to install a tool and you didn't put it on that list, well, now that user has an availability issue. And now he probably has to go through the proper channels to get you to allow that application through, thus causing more administrative overhead. A block list, sometimes called a blacklist, will deny only specified applications or services, but anything not on that list will be allowed to be installed. So this is sometimes considered not as secure, but it's less administrative burden, and it will prevent you from installing known malicious applications. Some more application security. So in application security, we must take an agile approach to secure our code during the development process. The Security Plus exam wants you to know about different software development lifecycle techniques. However, in a real production network, most successful companies that treat IT as a core business competency will use an agile approach and implement DevOps slash DevSecOps into their deployments and development. If you guys want to learn more about that, I recommend you read something called the Phoenix Project in the DevOps Handbook. But now back to the Security Plus exam. And now let's talk about the different SDLC models: Agile, Waterfall, and Spiral. Agile is an SDLC software development lifecycle concept that implements continuous improvement and allows flexibility into the code by using customer input to constantly change code or application requirements. The Waterfall is an SDLC that works chronologically and only allows developers to move on in the development lifecycle once the previous step has been completed. Spiral is an SDLC that combines both these approaches. So as a security administrator, it is essential that you know how the software development lifecycle works and where you can implement secure practices into the software development lifecycle. There are many different resources on the internet that can help you secure your organization's websites and applications, like the OWASP project. There's different frameworks that you can use, like the MITRE framework, that can kind of show you how to start developing those processes into development and to secure your applications. And then we have static code analysis. This is a protection technique that involves senior developers or security personnel combing through the source code of an application to correct insecure coding practices. This is sometimes referred to as manual code review. Then we have dynamic code analysis, which involves executing the application or website to test how it reacts to error handling, injection attacks, and input validation. The dynamic analysis will be conducted once the code is complete and should be performed before the code is pushed into production. Dynamic analysis can involve doing stress tests that will gauge performance. Dynamic analysis can also strictly be for testing the security measures that should be in place, like proper error handling and input validation. Fuzzing is a form of testing or maybe an application that involves sending random input and invalid data to an application or website to test how it reacts. When you fuzz an application or website, I call that throwing the kitchen sink at it, right? You're going to send so much stuff to see how it responds, make sure that you have a good analysis of how that that application will respond. Now let's go over some hardening techniques. Hardening is a security technique that will help protect your systems at the lowest levels. Hardening involves an administrator setting baseline or standards and then enforcing those standards on all endpoints or network devices. Disabling open ports and disabling unused or unneeded services is one hardening technique we can implement on our systems to lower our footprint / vector of attack. Now, in some scenarios, it may be prudent for us to disable ports facing outside our network, but keep those ports internally open on our network. For example, we may need to use SMB, the Simple Message Block Protocol, for file transfers within our network. However, SMB is highly vulnerable, and it shouldn't be open towards the internet. So what do I mean by this? Let's say we have a screen subnet here, right? And then this is our enterprise. And in this screen subnet, we have some internet-facing servers. Well, maybe that file server needs to have SMB open to our enterprise, but it shouldn't be open out towards the internet, right? So that's just one of those hardening techniques that you got to keep in mind, right? You can't maybe disable something completely. Maybe you got to disable it inbound or outbound. Now let's go over registry hardening. The registry in a Windows system is how a Windows system tracks everything in the operating system. We can harden our registry by implementing access restrictions, disabling the remote registry access, and disabling the reg edit tool on our end user devices so end users aren't able to mess with the registry editor, which can really affect your systems if someone messes up a key in that registry editor. Next, let's go into some OS hardening. OS hardening is another technique we can use in our enterprise to create a better security stance in our networks. OS hardening involves configuring systems OS to our organization security standards and correcting any system that does not adhere to our security baseline. OS hardening can be done using group policy objects, maybe having a standard image for your enterprise or certain departments, or something as simple as having a standard naming convention for all of our systems. Patch management is another necessity in our network / enterprises. Patch management ensures that our systems are getting regular updates and are protected from vulnerabilities that will arise in our systems. Patch management systems can come standard with some operating systems, like the Windows Update tool, or they can be a third-party tool that will scan your network and implement patches automatically or manually from the administrator. The benefit of using a third-party patch management tool is that you can patch different systems simultaneously instead of relying on a single vendor's patch management system, right? So let's say you got Linux and Windows and Cisco all in one enterprise. Maybe with that third-party patch management tool, it can go through and patch different Linux distributions and different Windows distributions, like Windows 10 or 11, right? If you're still running them. So some pro tips, right? So when a user complains about a slow computer, check to see if it's been updated recently. Keeping enterprise computers as up to date as possible will help prevent this, right? Some more hardening techniques. Another hardening technique is disk encryption, which will protect our data at rest on our systems. A self-encrypting drive is designed to encrypt and decrypt drive data without the need for user input. So this is again just full disk encryption, but it's self-encrypting a little bit more automated, right? And now let's go over full disk encryption. FDE will encrypt your entire hard drive and require a key, typically a PIN or a password, to decrypt your drive and allow you to interact with your system. FDE should always be used in the enterprise. Specifically, if users in your enterprise will be traveling with your equipment, FDE will protect your data in case a user's laptop or cell phone gets stolen. And now let's go over some more hardening. So, a hardware root of trust is a scheme that relies on a chain of trust that will verify the integrity of each component of a computer, starting with the initial boot process. As you can see on this diagram, right, it starts at the root TPM, the trusted platform module, which verifies the integrity of your boot process by comparing hashes, right, which we talked about. And then it moves on to your firmware, making sure that it's OEM, right? Because you already did this TPM, so now the firmware can be loaded. And then once you do that, it moves into the OS, making sure the OS hasn't been changed, possibly by comparing some hashes, right? And then finally, you'll be allowed to use your system as it should be and start doing some work, right? The diagram shows you going into apps, but really that's just saying, okay, you're on your system now, go use your email, go use Word document, whatever you need, right? To perform your daily roles. So, a trusted platform module. TPMs are chips used in hardware to provide built-in encryption and security functions to our hardware, right? So we said TPE can provide, or TPM, excuse me, can provide hashing that we compare on our boot, right? And then a final hardening technique we will cover is a sandbox. A sandbox is a virtual or isolated environment where you can test software or detonate malware to see how the malware functions. Now, sandboxes can be as simple as a virtual machine, or they can be complex and try to mirror your entire enterprise. Maybe make a staging area with the sandbox. When sandboxes are used for developing/staging environments, they are typically replicas of the production environment. And there's a lot of sandbox solutions out there nowadays that you can use to rent out for maybe labbing space for your enterprise or for your developers. All right, so I know that was a long video, but I want to thank you for staying with me and thank you for viewing. And stay tuned for our next video where we will discuss Domain 3.3 Secure Network Designs. Thank you.